Right. So this is the new lesson, the fourth one, the logic gates with Boolean functions, right? Now here we are going to learn about how the electronic science works inside the computer, right? So when it comes to the electronic science, gates is the basic component that we are going to talk about, right? So you are going to learn about a new friend called gates, and you will realize what happens when the gates are being functioning inside the circuits, right? And you will realize it is the one which helps the computer to understand how ones and zeros are going to be managed and how it is being processed likewise, right? And people, can anyone confirm whether my voice is clear with you or not? Yes, anyone? Right, okay. Right, great. All right, let's jump into the program. So when we consider the computing, or the electronic components inside the computer, it is powered up by the electricity, as we all know, right? So like if we think about of these ones and zeros onto its lowest point, right? අපි හිතාගෙන එයාගේ පිටිපස්සෙම point එකට ගියොත්, like at the ultimate end we are talking about the velocity difference, right? Or the electricity flowing and not flowing situations, right? So as per our easiness, right, for our comfortness, we indicate these high voltage and low voltage situations inside the electronic circuit as the 1 and the 0, right? When we are doing the number system lesson, we talk about this, how ones and zeros, why ones and zeros are there, right? So now here we are going to talk about what happens to that ones and zeros when they are flowing through the circuit, right? Now if you take a look into a motherboard, you can see various different kinds of components on the motherboard, and you can see, in most of the ways, you can see the ICs, integrated circuits, which is fixed into the motherboard, right? Some black color chips kind of things, right? There are a lot on the motherboard, right? Now if we decompose that particular ICs, the gates will be the basic components which is acting inside it, right? So when it comes to the circuit and the gates, we are going to introduce with three basic gates which we call NOT, AND, and O. Some funny names are there: NOT gate, AND gate, and O gate, right? And using those basic logic gates, we are creating combinational logic gates, right? So today we are going to learn how these basic logic gates are being made, or what is the nature of them, and how the combinational gates are being made, right? Okay, so everyone have the heading logic gates with Boolean functions. I'll give you a minute to write down the heading, so then we can carry on. Right. So people under this, let's just have a very simple 2-3 sentences regarding this. Let me see what are the things that you need to get down. Yeah. So under that, have the first subheading logic gates and copy this particular sentence. And people, it's better we take down the next two rows as well, right? Take down the entire one. Then we can go for the little diagram. Okay, are we done? One is done. How about others? Yes, others, are we done? All right, so let's go forward. So we are not going to draw this diagram, this particular one, right? So let's have this classification. Now, these are the symbols of the basic logic gates, people. So there is a symbol, and as well as you can see, there is a component called truth table, a little small table called truth table. අපි සිංහලෙන් කියනවා සත්‍යතා වගුව කියලා, right? So these truth tables will define how these gates are going to work, right? So let me summarize that to you so you can have that note on your book, right? All right, here we go. So let me explain first. Now, when it comes to the logic gates, right, we have two types of logic gates, which are called basic logic gates and the other part is combinational logic gate. Right, so basic logic gates later divide into three parts or three types. And as I told you before, they have some funny names, right? What are these funny names? One is called not, the other one is called and the other one is called o, right? And it is given this kind of funny names because of their operation, right? So one is called not, the other one is called and, the other one is called o, right? So when it comes to the not, o, and, they have their own type of symbols, right? This is the not gate symbol. And this is the AND gate symbol. And this is the O gate symbol. Right? So something very easy to remember. Right? So not, and O. And when it comes to a gate, the lines that you can see in the left-hand side, are called input lines. These are called input lines. Right? And these are called output lines. Or sometimes it is called output, just the output. Right? So NOT gate has one input line and one output line. AND gate has two input lines and can have more. Minimum is the two. And one output line, that's only. They can't have more output lines. OR gate, again, minimum number of input lines should be two. And it can have more. And output lines, again, just one. Right? Okay. Now, when you consider a particular gate, it has this way of treating the ones and zeros according to its nature, right? Each and every gate treating the ones and zeros, which is receiving as inputs in three different manners, right? So to indicate these things, we use some symbols. The operation, to indicate the operation of the particular gate, we use some symbols and operators. These operators are called Boolean operators. I'll tell you why it is called Boolean operators very soon, right? Because this logic gate section is talked under the Boolean logics. Boolean logic means none other than being true and being false, right? අපි computer එකේ ones and zeros ගැන කතා කරනවානේ. Ones and zeros කියන එකත් logically අරගත්තොත් Boolean algebraic method එකට match කරොත් it one is representing the value true and zero is representing the value false, right? So likewise, these gates are having their own specific operation. So we indicate it like this. When some variable, let's say a, is given to not, we say not is outputting a bar or a dash. That is the way we are going to write it. A bar or a dash, either of them. So a is given, a bar or a dash is output, right? And we say when we give a on this particular line and when we give b on this particular line, this output a dot b. Ravidu, I'll come to that, Pudha. I'll come to that, right? And when it comes to O, we say this is doing Boolean addition. So once A and B is given, this is giving you A plus B, right? So now you can see some familiar operators right over here, neither. If you take the multiplication in mathematics, we indicate multiplication by a dot. Addition in mathematics, we indicate it using a plus. So the same way, we call this AND operation as the Boolean multiplication. It's not just the multiplication, we indicate as Boolean multiplication. As I told you, this is said as Boolean because it is working with ones and zeros. In other words, the values of true and false. And O is considered as Boolean addition. So what is this Boolean addition and Boolean multiplication, and why? What is this A bar and A dash? We call it the complement, right? To describe what actually happens with this A and B, we illustrate it using a small table. We call it the truth table of a gate, right? Later we are going to learn how to draw a truth table for a given circuit. But at the very first stage, we are learning how to draw a truth table for a particular gate, right? So this is what is happening. Ravindu, you may receiving the answer via this, right? Now, if I draw the truth table for the NOT gate, now truth table basically having the input, the possible input values and the corresponding output values. Possible input values and the corresponding output values. So as per the diagram I have drawn here, my input is A. It can be considered as A, and my output is A dash or A bar, right? A bar or A dash. So now NOT gate is a special one. I couldn't tell you. This NOT gate can only have one input line and one and only. It cannot be increased further than that. Definitely it cannot be decreased, right? So only one input will be there. Then that input could be a 0 at some stage. Sometimes it can be a 1, right? May not get input line එකට එන value එක. Told you the computer is working with ones and zeros. No? So when there is only one line at a time, it can receive a one particular response. So it's going to be either 1 or 0, right? So A can be 0 as well as A can be 1. So if 0 is given, now what's happened when it is going through this logic gate, the NOT gate, this triangle and the little circle? So we call it, the input value will be inverted, right? So simple term, change into its opposite, right? So when a particular input goes through a NOT gate, it will produce, or it will output the opposite of the input, right? So 0 is given, the opposite of the input is going to be 1. So 1 will be the output. And when 1 is given, the opposite of the output, opposite of the input, or the inverted value of the input. So 1 will become a 0 when it is flows through a NOT gate. Right? People, is that clear? Ravindu, is your question is being answered? No, Ravindu. Dash and bar, Ravindu, to indicate that a particular variable, මේ අපි A කියලා ගන්නේ something that we don't know. So A bar will indicate, okay, whatever is being input, now it is being complemented. Yeah, උදාමයා දුව මෙතන අපි කරන්නේ, since this is a circuit kind of a thing, circuit will have an input and output. මේක හරියට ඔයගොල්ලෝ පොඩි සෙල්ලම් බඩුවක් කියලා හිතන්නකෝ. සෙල්ලම් බඩුවක් නෙවෙයි, ඔයගොල්ලෝ පොඩි කාලේ නේද? කාටුන් වල දැකලා තියෙන magic boxes. So we have these magic boxes, 3 types of magic boxes, right? So one not කියන magic box එකට තියෙන්නේ අපිට මේ input කරන්න line එකයි. හිතන්නකෝ අපි ඒ box එකේ සිදුරක් තියෙනවා කියලා. එතකොට මේ box එකට input කරන්න පුළුවන් එක දෙයයි. input කරාම box එකේ එහා පැත්තෙන් තියෙන output line එකක්. ඒකෙන් අපිට දෙන්නේ input කරන කෙනාගේ complete opposite එක. එතකොට not box එකට අපි 0 දැම්මම අපිට output එක පැත්තෙන් එන්නේ 1. 1 කෙනෙක් input කරාම output එක පැත්තෙන් එන්නේ 0. තෙසඳු අපි තාම මුකුත් ලිව්වේ නැහැ. පොඩි දෙයක් ලිව්වා තෙසඳු. I'll show you that. Then still we are like discussing the things. Right? Udame, are you getting the picture now? Now, don't take it like rocket science people, right? It's just very simple thing, right? You got a particular symbol, and we can give inputs to that particular symbol, so it will output the opposite of the input, right? We call it the inverted value. Very good, Dinelka. That is what the bar is there for. So A's inverted value is A bar or A dash, right? So we can represent inverted value of a particular variable. Variable එකක් අපි ගන්න දැන් අපි mathematics වල අපි variables ගන්නවනේ. When we don't know what's the value is, we took a variable. So likewise, if A is a variable for a NOT gate, A bar will indicate the opposite of that, or the inverted value of A. So if A is 0, the inverted value will be 1. If A is 1, the inverted value will be 0. So in other words, if A is 0, A bar will be equal to 1. If A is 1, A bar will be equals to 0. Ravidu, when we have the value, it's the opposite of the value, Puta, not the variable. අපිට variable එක input කරාම තමයි රවිදු variable එකේ complement එක. ඒ කියන්නේ a bar හරි a dash හරි කියලා ඉන්නේ. When we have the values, we know the logic, no? It's the complete opposite of that value. So when we have 0, we are not going to indicate output from A, Ravindu. When we have 0, it is very clear the output will be 1. When we have 1, it is very clear the output is going to be 0. But when we have A, the output is going to be A bar. Likewise, if I say when we have B, what is going to be the output when it's go through the NOT gate? It's supposed to be, we have B as the input, B for ball. When if B is the input, what is going to be the output? Yes, or Sydney, B bar is the output. Well done. Right? Ramidu, are you getting this? Ravindu, is it clear? No. Ravindu, the bar and the dash are just symbols that we use. Instead of bar, we can use dash. That's what I'm saying. It's the same representation, right? So someone can say, once A is given, when it is outputted, it will be A bar, and as well as we can indicate it as A dash. So A bar and A dash means similar things, right? Got it, Ravidu? Yes, Tesandu, yes. Yes, Ravidu, A bar and the A dash are the same. Pehara, it is the standard that the Boolean algebra used, right? අපි දැන් අපි එක තැන්වල දැන් අපේ සිංහල වල අපි සමාන පද පාවිච්චි කරනවා වගේ, right? There are ways of representing those are the standards, right? So we can represent either from A bar or from A dash. Then ඔගොල්ලෝ science වලට ඉගෙන ගන්නවා නේද hertz කියලා unit එකක් ගැන, which is used to measure the frequency, right? So in science they say hertz equals per second. තප්පරයට කියන එකක් ගන්න පුළුවන්, right? So it doesn't matter, it's the same thing. It says A bar waliන් indicate කරත් A dash waliන් indicate කරත්, it's the same thing that they are going to indicate. So the people who have invented this Boolean algebra, or like this gate related section, they indicates you, okay, you can indicate either from A bar or from A dash, right? Pehara, is that clear? Yes, Ravidu, A bar and A dash are the same. Right? Okay, good, you asked the questions, right? That's great. All right, so any more questions? Can we continue for the to see how the AND gate is going to work? All right. Okay, let's go. Right. Then let's talk about the AND gate. Now, AND gate has two inputs. So I need two columns as my inputs, right? So I may name these. This is going to be the input, and these are going to be the outputs. So likewise, these two indicates the input, and our output is given as A dot B, right? So this is the output. Now, people, since we got two lines, two input lines, what are the combinations that we can have as the inputs, like from ones and zeros? Now, one will say A can have 0. At the same time, B is going to receive the 0. Yes, Sudamya. And someone can say A can receive a 0. At the same time, B can receive a 1, a different scenario. And someone can say there's another scenario where A can receive 1, where B is receiving a 0. Right? And someone may say where A is receiving 1, B can receive 1 as well. Can we have combinations other than this? Yes, people, can we have combinations other than this? Right? No, right? So it's only 4 things that we can do. Right? Neither අපි අර ශිෂ්‍යත්වයේදී අපිට ඔය වගේ ප්‍රශ්න එනවා නේද දෙන්නෙක්ගෙන් හදන්න පුළුවන් රටා මොනවද? Right? Likewise, these are the combinations that we can solve. Now, what happens to the output when this input combination is given? What happens to the output? Output will produce the multiplication of these inputs, right? And it's better you remember it's the Boolean multiplication that you are going to receive, not just a multiplication. Multiplication is a mathematical or a algebraic term. Boolean multiplication is a Boolean algebraic term, right? When it comes to the gates, we are talking about Boolean values, right? That means true and false, which is indicated by 1 and 0, right? 1 is for true, 0 is for false, right? Now, what is happening here? It is just multiplying. So like actually when it comes to the Boolean multiplication, it is very same as the mathematical multiplication, right? So the answer is easy. 0 into 0 will produce 0. 0 into 1 will produce, is it a 1? No, it's going to be a 0. 1 into 0, it's going to be a 0. 1 into 1 will produce 0, 1. Yes. People, did you get that? So we know what are the combinations that can be there into one, A and B. And according to the inputs, output will be produced as a multiplication, right? So it's A dot B. So 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. Got that? That a pretty advanced question that you have asked. If the AND gate has 5 inputs, like 5 inputs means like you indicate like 5 lines will be there at your left hand side. Is that what you mean? Yes. Now, when it comes to the 5 input lines, there will be 32 different combinations. 32 different combinations. And like when we are advancing through the lesson, we will see what happens when 3 input lines are there. So when you will find when there are 3 inputs, there will be 8 combinations, right? So the inputs and combinations are having a relationship of 2 to the powers. Like number of inputs are taken as a 2 to the power, it's going to show you how many combinations are there, right? So for O levels, we just go only for 3 inputs, only maximum 3 inputs, right? In A levels, we go maximum 4 inputs, right? And going for 5 inputs, that's why I told you it's pretty advanced, right? But you can think. Okay, we'll talk about it when the time comes, right? Okay. So now that is the deal of the AND gate. And people, we can find a pattern out of this, neither. Yes, Sudamya. Actually, Udamya, it's not 2048, it's 1024, 2 to the power 10. 2 to the power 10. 2 to the power 10 means 1024, Udamya. Right? 2048 is going to be 2 to the power 11. Right? Good, good. It's good you people think on that manner, right? That's brilliant. Right? Okay. Now we can see a pattern over here, people. Can you recognize like to output a 1 through a AND gate, both the inputs should come as 1. If either of the input indicates a 0, you are going to receive a 0, right? So it's better you remember the pattern. Why I'm saying this, in the examination, they are just giving you similar kind of patterns and ask which kind of a gate that you can map into this situation. So they will say, okay, there is this some particular thing which gives 0 in 3 particular scenarios, and when we'll be receiving 1 in a 1 particular scenario. So what kind of a gate is mapped with this? So you have to remember, okay, there is a gate, something like this. When both the inputs are 1, it produces a 1. If one of the inputs are 0, it produces 0. So it is an AND gate, right? So likewise, just have that in mind. දෙන්නම එක වුණොත් තමයි එක කියලා output වෙන්නේ. In all other cases, AND gate give you a 0. Right? And you will find this is pretty interesting when it comes to the questions, right? එනිකන් හරියට අර අපි තේරවිලි විසඳනවා වගේ ආන්නේ වගේ තමයි. Right? Okay, let's look into the gates question. I'm sorry, the OR gate. Right? Now OR gate has 2 inputs as well. I told you the minimum is 2, right? It can have more, right? So the same truth table, like same combinations will be there, right? You can understand that. So OR gate has A as well as B, and the operation happens in between A and B through a OR gate is A plus B. We call this a Boolean addition. A Boolean addition, right? So in this truth table of the AND gate, I'll write this word called Boolean multiplication, right? So as previous, these will be the inputs. This is the output, and this is called Boolean addition. Now the combinations are not something new for us. We know how the combinations are going to be now. The question is, what's going to be the output? Now, since this is a Boolean addition, it is almost similar to the mathematical addition, but there is a one special addition which is differs from the normal mathematics, right? It is the place where you find 1 and 1 as the inputs. Now, in all other scenarios, when A and B receives 0 and 0, 0 and 0 will be added together and given the answer, which is 0. When 0 and 1 is received, 0 and 1 will be added together and given the answer. When 1 and 0 is given to A and B, 1 and 0 will be added together and given the answer. When 1 and 1 receives, it will be added together, but your answer according to the Boolean addition is going to be 1. Mathematically, it's 2, but Boolean algebraic methods will prove 1 plus 1 equals to 1 in Boolean algebraic methods, right? I'll tell you why it happens, right? It is because I told you the 0 indicates a false and 1 indicates a true. So when you add one false into another false, it becomes a false, one particular big fall, right? And according to the Boolean algebra, when false do the plus operation with a true, it's going to provide you a true, right? It's the way it happens, right? Addition. But when a true is added up with another true, it produces you a true again, right? So the picture will be very clear with you if you think about the electricity. So think about 0 is a position where you don't have any electricity, and 1 is a position where you have the electricity. So when no electricity combines with another no electricity situation, so again it gives you no electricity situation, right? And when no electricity situation is combined with a situation which has the electricity, so finally it gives you a place where you have the electricity. Circuits electricity නැති circuits දෙකක් එකට combine කරාම still it doesn't have any electricity. Electricity නැති circuit එකක් electricity තියෙන circuit එකක් එක්ක combine කරොත් the total circuit is going to have the electricity. So the answer is 1. So electricity තියෙන circuit එකක් තව electricity තියෙන circuit එකක් එක්ක combine කරාම it doesn't going to make double electricity. It's just flow. The electricity will flow through that as well. So that means electricity is there, right? Yeah, Ravido, I'll tell you. Now, when you need to do the Boolean addition, Puta, think about මෙහෙම හිතන්නකෝ. දැන් මම අහන එක චිර හොඳ නෑ. කරන්ට් වැදිලා තියෙනවද? Right? සමහර අයට කරන්ට් වැදිලා නැතුව ඇති, right? Then like if a particular wire okay, right, then අපි අරගත්තොත් කරන්ට් එක තියෙන වයර් එකකුයි කරන්ට් එක නැති වයර් එකකුයි, right? එතකොට ඔයගලගේ 0 position means both the wires does not have a current. So when we combine that, when we add those things together, when we connect those things together, does it provide you electricity? It won't, right? So it is something which you can map with 0 plus 0, which will give you a 0 again, right? And 0 and 1 means one particular wire is not having a current and the other particular wire is having a current. So when those two combines together, both the wires will have current. Now that means it is 1. then දෙන්නටම current එක තියෙනවා. That means 1. Right? එතකොට right. So when you combine two wires which has the electricity, definitely it is going to have a spark, right? But if you connect it, both will have the current. So having the current indicates as 1. ඔයගොල්ලන්ගේ textbook එකේ තව ලස්සන examples තුනක් තියෙනවා මම එතනටත් එන්නම්, right? So you can have that picture like that. In simple way, දැන් ඔය current එක ගැන, voltage ගැන, මුකුත් ගැන හිතන්නේ නැතුව simply we can take it like this. When you are doing the O operation, the Boolean addition operation, with a 1, එක කියන එකක් එක්ක Boolean operation එකක් කරනවා නම්, can at least එක්කෙනෙක් හරි එකක් වුණොත්, your output is going to be 1. If both are 0, then only your output is going to be a 0. Simply මතක තියාගන්න විදිහ. Right? If any of the inputs are 1, the output is going to be 1. If none of the inputs are 1, your output is going to be a 0. Right? Are you getting this, people? Right, okay. Now, before we write this down, I'll take your attention to your textbook. Now here how they have indicate the AND gate, the workings of the AND gate. They have used a electric circuit. Now, the inputs of this AND gate circuit, they consider it as A and B. Then A and B කියන දෙක අපි දැන් මේ science වලට accordingly අරගත්තොත් these are switches නේද? A and B are switches. Now, to light up the bulb, both the switches should be closed. The switch එකේ close position එක ඒගොල්ලෝ ගන්නේ 1 කියලා, open position එක ගන්නවා 0 කියලා. Right? So when A and B both are open, bulb is not going to be light up. If any of the switch is acting as a close, like any one of the switches is on the close position, still bulb is not going to be on. A close color, B open tibbot, it's not going to be light up. If B is closed and A is open, still it is not going to be light up. Right? Both A and B is closed, then only the bulb will be light up. Right? So if we think about open position as zeros, closed position as ones, it will clearly map into a AND circuit, right? Or the AND gate. Tesandu, here they don't have a AND gate පුතා. මේ AND gate එක වැඩ කරන විදිහ තව circuit එකක් එක්ක ඒගොල්ලෝ map කරලා පෙන්නන්නේ. කියන්නේ මෙතන AND gate එකේ AND gate එක වැඩ කරන්නේ මෙහෙමයි කියන එකයි ඒගොල්ලෝ පෙන්නන්නේ. right? නැතු AND gate එකක් මෙතන නැහැ. Right? Right? What they are trying to say is, right? So මේ open position එක 0 ගත්තොත් මෙතන තියෙන්නේ 0 0. මෙතන තියෙන position එක 1 1. So bulb එකේ off position එක ඒගොල්ලෝ 0 කියලා අරගෙන තියෙන්නේ, on position එක 1. right? එතකොට මෙතන තියෙන logic එක තමයි switch is open indicates 0. Switch is closed indicates 1. Bulb is Api bulb is on කියලා ගමු. Bulb is on indicates 1. Bulb is off indicates 0. So it's kind of working as an AND gate. AND gate එක වගේ වැඩ කරන්නේ. AND gate එක විදිහට අපිට මේ circuit එක ගන්න බෑ. නමුත් මේක නිකන් AND gate එක වගේ වැඩ කරන්නේ. මොකද එතකොට අපි AB කියන switch දෙක ගත්තොත් දෙන්නම open නම් bulb එක පත්තු වෙන්නේ නැහැ. This is the bulb. Bulb will be the output. Bulb is not lighting up. If A is closed, B is open, still bulb is not going to light up. If the A is open, B is closed, still bulb is not going to light up. If A is closed and B is closed, then bulb is going to light up. Right? So they have given you some explanation to show how the operation of the AND gate looks alike. Right? Okay, so likewise we can indicate this, the operation of the gate, from many different scenarios. Then ඉස්සරහට ගියාම ඔයගලන්ට තේරෙයි අපිට ඒගොල්ලෝ scenario එකක් දීලා circuit එකක් හදන්න කියනවා. ඒ හදන්න කිව්වමත් අපි මේක මේ විදිහට පොඩ්ඩක් logically හිතලා බලන්න ඕනේ. We go to that, right? We are just starting the things, so don't worry. Right? Okay, people, what I need you to do is I want you to write these things, and let's start from here. Yeah, do it like this, people. Draw a one diagram just by indicate these three. Right? Ek diagram එකක් මේ විදිහට අඳගන්න. Logic gates, there are two types, basic logic gates and combinational logic gates. And later draw another diagram to show the deviation of the basic logic gates. The basic logic gates කියන එක ආයි වෙනම අරගෙන ඒක මෙහෙම තුනකට කැඩනවා කියලා ඒක වෙනම diagram එකක් විදිහට පෙන්නනවා. Right? So it starts from this end. ඔය විදිහට අරගෙන මේ ටික වෙනම diagram එකක් විදිහට පෙන්නනවා. Right? This is separate the second diagram. Right? First, you may write the first diagram, the blue dashed area. Logic gates, two types, basic logic gates, combinational logic gates. That's all. That's the first diagram. Then under that, the second diagram about the basic logic gates. Right? Okay, hurry up. So I'm moving the diagram a little bit up. Hope you are done with the first diagram, basic logic gates, divided into two major parts, which is basic and combinational logic gates. So this is the basic logic gate situation. There you go. Okay, one is finished. Yeah, Tesandu, Boolean කියලා කියන්නේ පුතා ඒක කියන්නේ logic gates කතා කරන section එකේ ඒගොල්ලෝ address කරන විදිහ. ඒ කියන්නේ දැන් අපි බීජ ගණිතය කියලා තියෙනවානේ අපේ mathematics වල algebra කියලා part එක. ඊට පස්සේ තව part එකක් තියෙනවා trigonometry ත්‍රිකෝණමිතිය පැත්ත. Right? So geometry ජ්‍යාමිතිය. ඒ වගේ පුතේ logic gates ගැන කතා කරන නැත්නම් logical operations ගැන කතා කරන area එකට තමයි අපි boolean algebra කියලා කියන්නේ. Right? It's kind of a science. Right? Two are done. How about others? All right. Okay. Is there anyone still writing this? Or else we can proceed.
Look at me. I'm pretty.
Okay, Ravidu, keep it up, keep it up.
Goodbye, Daddy.
Okay, let's move forward. Now, let me take a look at of your textbook. Yes, now they are just explaining the things that we have done, right? So we are not going to write those things. That is what we have sum up.
We didn't. Doctor didn't got wobbly tooth.
No.
Oh, did I got wobbly tooth?
All right.
No, I got a shiny tooth.
Right, Lamai. Just looking at this and tell me what is the output of the P and Q. Yes, what's going to be the P? Type me the answers. Yes, Pehara, that is correct. Yes, Ravidu, that is correct. Yes, yes, that is correct, people. That is correct. Udamya, don't go with the ones and zeros, Dua. It's better you go with the variables that they have given, A and B's. Right? So P is equals to A dot B. That is correct. Since it is an AND gate, P equals A dot B. And how about Q? Yeah, Dinelka, that is correct. Yes, Pehara. Now, that is also correct, Pehara. P dot C kira tapir kiyanna puluwan, but when if they ask Q uh, from A and B and C, so it is Q is equal to A dot B dot C. Yes, that's right. Right. And yeah, here's something for you to do. Right? How it's going to be? What are the values in A dot B? Right? Let's do it like this. Now you tell me the answers for these places. Number one. Now let's do it like A, B, C, D. A, B, C, D, and E. What are the values for A, B, C, D, E? And you can shortly specify who got 0 and who got 1s. 0 enne mona kuruwaltada, 1 enne mona kuruwaltada kiyala specify karanna. So that will be enough for me. Who got zeros, who got 1s? Yes, Ravindu, that's correct. A and B is correct. Oh, Ravindu, look at the C. In C, A is 1, B is 0. So 1 dot 0. Ravindu, D. How about D, Ravindu? Is it 0? And yes, yes. Okay, lot of you are sending me the answers. Yeah. There are 2 positions which receives 1. There are 3 positions which receive 0. A, B, C. Because A is 0 into 0, which is 0. B, 0 into 1, which is 0 again. C, 1 into 0, again a 0. And these two, 1 into 1, will give you a 1. So A, B, C will receive you a zeros. D and E will receive you 1. Yes. Right? So all you have to do is remember the logic. That's all. Right? Good. Brilliant. Let's see what they have given in the B, the O gate with the O gate. Okay. Yeah. So as we saw it in the AND gate, the 3 input AND gate can be drawn as using O gates, which has 2 inputs like this, right? So the same output that you are going to receive, right? So this particular picture in Q, you are going to receive A plus B plus C because this is an O gate. Here, you are going to receive A plus B over here and C is receiving over here. So Q is equals to A plus B plus C again, right? So something very simple, right? So The NOT gate, yeah. So as we talk about, the things are going to go like that. And then after, we are going to talk about combinational logic gates. Now, combinational logic gates, you are given two types of things, NOR and NAND, I guess. Now, when it comes to the A levels, you will be finding something different, right, than this. But, oh my God, where did I went? Yeah. And for combinational gates, there are two type of things, which is NAND and NOR. And who are these two? Now, these two are like this. Now, in combinational logic gates, I'll tell you the story over here, right? In combinational logic gates, there are two types. One is called NO. Other one is called NAND. Can you find anything familiar? We know O and we know AND. It has an end in front of it, right? Now, once you know how this NO and NAND was formed, then you will realize what happens here, right? So NO is made using an OR gate, and to the output of that, they fix a NOT gate. Now, that is the logic behind this. So when A and B is input over here, you will receive A plus B as the output. And once it is went through the NOT gate, it's going to be A plus B, the entire term is going to receive a bar. A plus B bar. Or A plus B brackets outside the brackets, you are going to put a dash. Right? Now, this is the logic behind this. So the actual symbol of the NOR gate is drawn in this particular manner. And the actual symbol is drawn like this. We take an OR gate, we concatenate the dot of the NOT in front of it. So this is the symbol of the NOR gate. People, are you getting this? How the combinational circuit happens. That is why it is called combinational circuit. Then combine the OR gate and the NOT gate. Together, it performs NOR gate. Right? So once you given A and B, you can straight away write over here A plus B total bar. Yes, everyone, is that clear? Right. So the same way, very same way, NAND has made according to the very same logic. How A and B inputs gone through an AND gate and the output is going through a NOT gate. So this is A dot B and A dot B total bar is going to receive. So now you can figure out what's going to be its symbol, neither. A and B will be inputs to an AND gate, and the dot of the NOT gate will be there, and the output will be there. So we put the output A dot B total bar. Yes, Ravindu, no problem. We can use the dash. When you are putting the dash, put it outside the brackets. So like I'll write it to you in here as well. Right. Hold on, my yeah. What is this? Okay. Or you can say A plus B dash here as well. A dot B dash. Right? Got it? Yes, yes, Dinelka. In combinational logic gates, you always find a not in front of it. Right? ඔගොල්ලෝ දැන් A levels වලට ආවම අලුතෙන් එක්කෙනෙක් ඔයගොල්ලන්ට හඳුන්වලා දෙනවා nor and I'm sorry XOR and XNOR කියලා කෙනෙක්. ඒක මෙතන syllabus එකේ නැහැ. If you really like to have the logic circuits, come and do the ICT in the A levels, right? So it will introduce you a new one, right? And people, what will be the truth table about these things? Right? It's simple, right? Now we can like think and write what are the truth tables are going to be, right? So I'm going to draw my truth table at the top and the bottom of these two, right? So you will be able to see it. Ah, no, let me draw it over here, then I can minimize the screen, right? So it's easy now. You know how to do this. You have A, you have B, and what you're going to find is A plus B total bar. You know how to add, you know how to complement. So 0, 0, 0, 1, 1, 0, 1, 1. So 0 plus 0 gives you 0. Once it is complemented, you are going to receive 1. 0 plus 1 gives you 1. Once it is complemented, it is 0. 1 plus 0 is 1. Once it is complemented or inverted, it is 0. 1 plus 1 is 1. Once it is complemented, it is 0. So this is going to be its truth table. Yes, Tesandu. Likewise. And what's happened to the NAND? A dot B total bar. So 0, 0, 0, 1, 1, 0, 1, 1. Right? So 0 into 0, it is 0. Once it is inverted, it is 1. 0 into 1 is 0. Once it is inverted, it is 1. 1 into 0 is 0. Once it is inverted, it is 1. 1 into 1 is 1. Once it is inverted, it is 0. Right? Yes. Ravindu, you are asking about the NO gate, right? උඩ තියෙන table එක ගැන නේද පුතා අහන්නේ? Yeah, Ravindu, now here the operation is you add those things together, then you complement it. That means converting the addition into its complete opposite. I උඩින් bar එකක් තියෙනවනේ. So 1 plus 1 is 1. Once it is inverted, 1 becomes a 0. Got that, Ravidu? Right, great. Okay, people, you can copy this down and then we can end our session for today. So please draw it as a separate diagram. Combinational logic gate is the heading. right? I'm not going to show it to you because you have it on your book, right? So combinational logic gates, then two parts. You have this. Oh, ඔගලන්ට මේක කැමැති විදිහකට පහළට පහළට ඇඳ ගන්න ඕන නම් පහළට පහළට ඇඳ ගන්න. You have the liberty, right? All I need is a clear note about this. That's all, right? So have this, and you can disconnect for today, right? So thank you very much, people. We are going to explore more about the gates when we meet next week, right? So please copy this, and then you can leave, right? Have a nice weekend, people. Thank you very much.